Today you're going to be seeing how to find the domain and range for two more function types. The first is like this, linear. And so we're going to start by finding the domain and range for a linear equation. So here y equals negative x plus 3. So in order to graph this, I think first, what does the plus 3 do? Notice there's no parentheses around the x and the 3. So the 3 is not in with the x. The 3 is hanging on the end, which means that the 3 is actually moving it up 3. So first thing I do is I plot that point up 3. Now the negative in front of the x, it's a reflection. And so instead of going over 1, up 1, I'm going to go over 1, down 1 from my starting point. And since this is going to be a line, it keeps doing that. And I know it's a line because there's no squared in there, there's no absolute value, there's no square root, there's no funky function going on inside of this. Anytime there's nothing else going on, it's just a line. All right, so now that I can see my graph, I can now think domain and range. So the domain, well, again, I can kind of think of starting at this point here, but from there it goes forever to the left and to the right. So my domain's going to be all real numbers. And the range? Well, the range, notice again, if I think of it as starting from that point, it goes forever up and it's going forever down. This is a line. It just keeps going forever in all directions. So both the domain and the range are all real numbers. Now, the beautiful thing is that that's going to be true for any linear equation as long as it's not a horizontal or a vertical line. So as long as it's not horizontal or vertical, your domain and your range will always be all real numbers for a linear equation. All right, let's do one more linear. Y equals 2x. If you're just listening to what I said, you should already know the domain and range. But if not, let's just double check. First up, I can make the graph of this. Notice there's no number added or subtracted on the end, so our first point goes at 0. And then the 2 tells me it's a vertical stretch by a factor of 2, so instead of over 1, up 1, we go over 1, up 2. And it is a line, so it keeps following that pattern. So now I can see my graph, but of course for the domain, notice my graph, if I extended out my graphing grid far enough, I could see it going on forever to the left, to any number I wanted to the left. Same thing to the right, it goes forever to the right as well. So my domain is going to be all real numbers. For my range, it goes up forever and it goes down forever as well. And so my range is also going to be all real numbers. Now, a few of you, when I first put up this equation, you might not have been thinking that it was linear because you saw 2x, and this year we've been dealing with a lot of equations that look kind of like that are written like this, 2 to the power of x. But notice that x was not written as an exponent. It was just written same size as the 2. So that told me it was multiplying by x, not to the power. But I do want to take a look at how to deal with the domain and range for those exponentials where it is 2 to the x. So that's the last thing we're going to be doing on this, is finding the domain and range for a couple exponentials. First thing I want to do then is I want to be able to see what the graph looks like. All right, and for this, the plus 1, it moves it up 1, and then it's 2 to the x. Now, this is what our graph looks like, but sometimes we have a little bit of trouble making that graph, and if you ever have trouble making that graph, remember, start by drawing in that dotted line. That dotted line represents the asymptote of the equation. That's just that line that it approaches but never crosses. And so, seeing that, we can see how we made this graph. We start by taking this plus 1, which moves it up 1, and that's where the asymptote went. And then from there, exponentials start up 1. Notice I'm counting from that dotted line. And then 2 to the x tells me double that height. So if that was up 1, I next go up 2. And then I double that 2 to go to 4. And I double that 4 to go to 8. If I kept going, it would then double to 16, and then 32, and 64. It goes up really fast, really soon. All right, now that I can see the graph, though, now we can talk domain and range. So first up, for the domain. My domain, it's the x values, remember. This graph goes forever to the left. It just keeps getting close to that dotted line, but never actually crossing it, but it keeps going to the left. There's always numbers over there. As we go to the right, it is getting super steep over here, But no matter how far over I go, like if I go over to 10 here, if I plug 10 into that equation, I'm going to have to go up a long ways, but I will eventually get to graph there. So my domain is going to be all real numbers. All right, next up for the range though is not going to be all real numbers, because for the range here, it starts at kind of where that dotted line is. It starts here at the 1, and so I want to make note of that first. My range is dealing with y values, and it's starting at 1, and it's going up from there. But notice there's one little difference. This one is not going to be a greater than or equal to 1, because my graph never actually hits 1 here. It gets super close to it, but it never actually hits 1. And so since it can get as close to it as you could possibly ever want, but it can't actually reach 1, we say that y is greater than 1, not greater than or equal to. Every other domain and range we've looked at, it's been an or equal to. This one is not, because of that dotted line that it approaches. All the other ones, it's or equal to because it actually starts at its vertex or whatever that starting point is for that problem. All right, we're going to practice one last one here. Exponential, y equals negative 2 to the power of x plus 6. All right, so think about how would you make the graph. And certainly with these, actually sketching it on paper first can be a huge benefit. So the plus 6, that determines that it's been moved up 6. That moves my dotted line up 6. All right, now I'd normally from there start up 1. But the negative, it changes that. The negative means start down 1. So there's my first point down 1. I've used the plus 6. I've used the negative. Now all I need to know is the 2 to the x. The 2 to the x tells me I'm going to double the distance from that dotted line as I go to the right. So if I just went down 1, I double that to 2. So I doubled that distance as I went to the right. And then I double that. So 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. That then gives me my graph. Now that I can see the graph, I can talk domain and range. Now, in the last exponential we saw, the domain was all real numbers because it went forever left and forever right. That's going to be true of every exponential graph. So this one is also going to be all real numbers for my domain. All right, next up, for the range. Well, range is dealing with y values. Notice my y values, basically the highest y value I reach here is the dotted line. So it's going to be y and it's going to be 6. But notice we're going down from there, so we're going to be below 6, but it never actually hits 6. Because remember, it never actually touches the dotted line. It gets super close to it, but never touches it. And so it's going to be a y is less than 6, rather than y is less than or equal to 6. And that pattern is going to hold for all exponentials. So for every single exponential equation, your domain will be all real numbers, and your range will be y is either greater than the asymptote or y is less than the asymptote. Never or equal to with an exponential. But every other one that we've done so far, it will be or equal to.